This lesson goes over the laws of exponents or some exponent properties. So I'm going to give you the properties and then we're just going to apply them. When you're multiplying, you add the exponents. When you're dividing, you subtract the exponents. And when you have parentheses, which I'll explain in a minute, you multiply the exponents. Now, in all cases, you keep the base. So what does that mean? If I have letter A down below, 2 to the 4th times 2 to the 5th, the rule is to add the exponents. So you get 2 to the 9th because 4 plus 5 is 9. In letter B, this negative 5 is being raised to the first power, so it's negative 5 to the 7th. When you're multiplying, you add the exponents. So in this one right here, x to the 3rd times x to the 7th, you just get x to the 10th, because when you're multiplying, you add the exponents. Okay, the next three are dividing. When you divide, you subtract the exponents. This is going to be 2 to the 2nd, because 6 minus 4 is 2. You keep the base, subtract the exponents. This is going to be negative 7 to the 6th. Don't forget the parentheses. 9 minus 3 is 6. And this is going to be h to the 1st, or just h. You don't need to write to the 1st. Now, the parentheses rule is not the official name. The official name is a power to a power. So when you have a power raised to another power, or what I call the parentheses rule, because there's always going to be parentheses involved, it's a parenthesis with an exponent on each side. When that's the rule, you just multiply the exponent. So this would be 3 to the 12th. This would be w to the 20th. When you have parentheses, or when you have a power to a power, you multiply the exponents. And this would be b to the 36th, because when you are raising a power to another power, you multiply. All right, using that idea, I'd like you to pause the video and do the on your own section. All right, take a moment, check your answers. In letter E, I didn't write to the first power because you don't need to write to the first power. But if you wrote to the first power, that's okay. Don't forget your parentheses in letter B, F, and I because you have those negative bases. The last property we're going to look at in this lesson is the power of a product. And the power of a product is kind of like the distributive property of exponents. So let's say we have the example 3 times 2 to the 5th. Now, why would you not say 6 to the 5th? I don't know. Just go with it. So what we would do is we would do 3 to the 5th times 2 to the 5th. Now, sometimes that's easier than doing 6 to the 5th, but just go with me. In algebra, let's just kind of say, if you're multiplying two things and you raise them to an exponent, you take each piece and you raise it to that exponent. So you're essentially distributing the exponent to all the pieces in the parentheses. So when we look at these examples, each piece is getting raised to that exponent. So in letter A, we're going to do 2 to the 3rd times x to the 3rd. Well, I can't do x to the 3rd because I don't know what x is, but I do know 2 to the 3rd, and that's 8. So the answer for this would be 8x to the 3rd. If you can simplify something, then do it. This is going to be 3 squared times x squared times y squared. So that's going to be 9x squared y squared. 5y to the 4th is going to be 5 to the 4th times y to the 4th. So calculators powered up. 5 to the 4th is 625. So that's 625 y to the 4th. this is just a to the fifth, b to the fifth, because I can't simplify anything. And this is going to be 0.5 squared, m squared, n squared. You should do 0.5 squared. That's 0.25. But you don't know the other ones, so you just leave it. You can also do more complex ones that use the same skills. So if we wanted to do number 1 and just simplify this expression, what I could do is I could add the exponents on the top because that's multiplication, and then I'll subtract the exponents on the bottom. So the numerator would give me 3 to the 6th because you add the exponents, divided by 3 to the 3rd, so that would be 3 to the 3rd. Now it says to leave it as a power, so I'm not going to do the calculation, but you could. In number 2, instead of going across first, you could also go down first. So this would be negative 4 to the 4th times negative 4 to the 6th, which would be negative 4 to the 10th. Don't forget your parentheses. Do the same thing in number 3. This would be a to the 4th because you subtract when you divide, times a to the 2nd, which gives me a to the 6th. Example 4 gives us a word problem. It says 1 gigabyte of computer storage space is 2 to the 30th bytes. The details of a computer are shown. How many bytes of total storage space does the computer have? So they're not asking us about the free space, so that's just kind of distraction information. They're just looking at the total space. Now it tells us that 1 gigabyte is 2 to the 30th bytes. So really I have 64 times 2 to the 30th, right? Because it's 64 gigabytes. So what I need to do, though, is you say, well, I can't type that in my calculator, because if you did, you'd get some crazy answer or you might get an error message because it's such a large number. 64 is, get this, 2 to the 6th. So it's 2 to the 6th times 2 to the 30th. So that gives me 2 to the 36th. So there are 2 to the 36th bytes of total storage space. And let's look at our last one of this lesson. The projected population of Tennessee in 2030 is about 5 times 5.9 to the 8th. Now, you can see this is why we don't really encourage the dot for multiplication when you have decimals, because it looks like a decimal. So they probably should have used parentheses, but like whatever. I'm not going to get picky. And then we have to predict the average number of people per square mile in 2030. So we're going to use this ratio, people per square mile, equals the population in 2030 divided by the land area. And they tell us in the picture the land area is 5.9 to the 6th. So if I set up my ratio, the population in 2030 is 5 times 5.9 to the 8th divided by 5.9 to the 6th. So let's divide this, and the way that we divide it is by subtracting the exponents because it has the same base. So it's 5 times 5.9 squared. So I can calculate that. That's not too big. 5.9 squared times 5 is 174. I'll round. 174 people per square mile. All right, if you have any questions, write them down and ask me when you come to class.